Okay, so here are the notes for the last two examples for implicit differentiation. So we're going to look at these two functions. I have a y equals that's in terms of v, and I have a v equals that's in terms of x. I want dy dx. The problem is I don't have a y equals that's in terms of x. So I have to do a little manipulation here. When I take the derivative of this function right here, that's going to be the derivative of y with respect to v. So that's going to give me dy dv. And then because I'm taking the derivative with respect to v, I don't have to do anything weird on the right-hand side. I just take my derivative because I am with respect to v, and I have all v's. When I do this one, I'm taking the derivative of v with respect to x's. So he is dv dx. So that would be 15x squared minus 11. Again, I want dy dx. What I have is a dy dv and a dv dx. I want a dy dx. Okay, look at what you have here. If I multiply these two things together, my dv's would cancel and I would get dy dx. So to produce a dy dx, I need to multiply dy dv by dv dx. So dy dv times dv dx. So that's going to give me dy dv is 16v minus 6, and I'm going to times that by 15x squared minus 11. Now technically that is dy dx. The problem is they're not going to leave the answer that has a v in it. If I want dy dx, then I want it in terms of x. Okay, well remember in your original, I knew what v was. So I can take what equals v and put it in for v. Now, they may stop here. They may distribute the 16 and then combine the negative 6, and then they may lobster the whole thing. I doubt it. If anything, they might distribute the 16. But, again, you're just playing the multiple choice game. Okay, let's try another one. Okay, so this one, and this one has different letters in it, so this is good. I want dy du. So I want to take the derivative of y with respect to u, which means I want u's in my answer. Dy du. Okay, if I look at this, if I take the derivative of this, this is going to be dy dx because I'm taking the derivative of y with respect to x. If I take the derivative of this one, this is going to be the derivative of x with respect to u. And again, if I want dy du, so if I look at this and this, if I want dy du, I can multiply these two together and my dx's will cancel. So what I'm going to do is I'm going to find dy dx, I'm going to find dx du, and then I'm going to multiply them together. So dy dx, so I'm taking the derivative of this with respect to x, so all is good. So 6x squared minus 8x plus 5. Then I'm going to take the derivative of x with respect to u, and they're u's in this problem, so all is good, and that would be 2u minus 1. Now I'm going to multiply these two things together so that I get dy dx, or not dy dx, dy du, because my dx's are going to cancel. Okay, but then here's the problem. If I want dy du, I can't have x's in my answer. I can have that u, but I can't have these two. So I need something that puts x in terms of u, and that's this right here. So I'm going to have 6 times u squared minus u squared minus 8 times u squared minus u plus 5 times 2u minus 1. And that is dy du. And again, they could clean that up or they could leave it just like that. If it's an FRQ, you leave it just like that. So hopefully this helps, but it's very important to understand the big picture of when you're taking the derivative of this, that's dy dx, and when you're taking the derivative of this, that's dx du, and then how to manipulate those two things to get what you want. Okay? All right. That's it. Good luck.